Hello student, good morning. I am Dr. K.Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have started new chapter, that is the fundamentals of reviewing gaseous state part 1. Gaseous state part 1 under state of matter. And I have discussed differences between solid, liquid, gases, means characteristics of solid, liquid and gas. Actually, I am reviewing the fundamentals of this chapter, states of matter. Also, you can tell gaseous state, part 1. Now, I am continuing expressing mass, volume, pressure and temperature of a gas. Actually, some relations are there that I am discussing. Number of moles, that is equal to mass in grams divided by molar mass. Many times I have discussed. And now further, mass of gas is determined. How will you determine mass of gas? Because gas mass will be very less. Then how will you determine? Then mass of a gas is determined by weighing the container containing the gas, then evacuating it and weighing the empty container again. Difference will tell mass of gas. Another important point relation you might be knowing, 1 liter is equal to 10 to the power 3 centimeter cube or cc, and that is equal to 1 liter is equal to 1 decimeter cube. So sometimes question is asked. Then 1 liter is equal to 10 to the power 3 centimeter cube, and that is equal to 1 decimeter cube. Further, 1 ml is equal to 1 cc, both are equal. 1 ml is equal to 1 cc, cubic centimeter. And 1 cubic meter is equal to what? You remember, 100 centimeter is equal to 1 meter. Correct? That you keep in mind. Then 1 cubic meter, that is equal to 10 to the power 3 decimeter cube. 10 to the power 3 decimeter cube. And that is equal to 10 to the power 6 centimeter cube. Means 1 cubic meter, that is equal to 10 to the power 6 cubic meter. And 1 meter cube is equal to also 10 to the power 3 liter, means 1000 liter. Correct? These are the relation. Sometimes in examination question is asked. Correct? Then 1 cubic meter is equal to 10 to the power 3 decimeter cube, that is equal to 10 to the power 6 centimeter cube, and that is equal to 10 to the power 3 liter. Now another relation, atmospheric pressure. Atmospheric pressure is measured. Actually, this concept you should know. Actually, I should remember the name of the instrument also. Important point of this chapter. Atmospheric pressure is measured with a barometer from the height of the mercury column that stands in a tube filled with mercury and inverted into a trough containing mercury. Okay, this question is asked. Atmospheric pressure is measured with barometer from the height of the mercury column that stands in a tube filled with mercury and inverted into trough containing mercury. Now another point, Pressure of gas. How will you measure the pressure of gas? What I told you now, atmospheric pressure. Now, pressure of a gas. How will you measure? Pressure of gas is measured with a manometer. Question is asked. Atmospheric pressure is measured with barometer, and pressure of a gas is measured with a manometer, and is equal to the difference in level of Hg, means mercury in the two limbs with a closed limb manometer, and is equal to atmospheric pressure minus difference in the level in cases or in case of an open limb manometer. Again I am telling you, pressure of gas is measured with a manometer and is equal to the difference in levels of Hg in the two limbs with a closed limb manometer, and is equal to atmospheric pressure. In shortcut, ATM pressure we can tell, and is equal to atmospheric pressure minus difference in level in case of an open limb manometer. Its relation you always remember, 1 ATM means 1 atmospheric pressure, that is equal to 76 centimeter. That is equal to 760 centimeter. Here 1 atmospheric pressure, that is equal to 76 centimeter, that is equal to 760 millimeter, and that is equal to 760 torr, TORR, torr. Okay, relation remember, 1 atm atmospheric pressure is equal to 76 centimeter, that is equal to 760 of Hg, and that is equal to 760 torr, TORR. And also 1 atmospheric pressure is equal to 101,325 Pascal, PA, in term of Pascal, 101,325 Pascal. Okay, or also you can tell in Newton per meter square. That also you can tell pressure, that is the Newton into Newton per meter square. Newton per meter square, that is equal to 10 to the power 5 Pascal. 10 to the power 5 Pascal, or Newton per meter square. Okay. Here again I am telling you, 1 atmospheric pressure is equal to 101,325 Pascal, or Newton per meter square is equal to how much? 10 to the power 5 Pascal. Approximately Newton per meter square is equal to 10 to the power 5 Pascal, or Newton per meter square. Okay, both are equal. Or you can tell 10 to the power 2 kilopascal. You want to tell in kilo, then 1000 30 remove, then 10 to the power 2 kilopascal. Now another relation, 1 bar is equal to how much? 0.986923 atmospheric pressure. 1 bar is equal to 0.98, very close to 100. 1, not 100, 1. 1 bar is equal to 0.986923 atm. Okay, atmospheric pressure. And 1 bar is also equal to 1 atm, 1 atmospheric pressure. 1 bar is equal to roughly 1 atm, that is equal to 76 centimeter of Hg, or you can tell 10 to the power 6 dynes per centimeter square. Correct? 1 var is equal to 10 to the power 6 dynes per centimeter square, or you can tell equal to 10 to the power 5 Newton per meter square. All are related. All are related, and you can calculate it also. All have link. Then 1 var is equal to, I told you, 0.986923 atm, and that is equal to roughly 1 atm. 0.98 means what? 1 atm. Correct? And 1 atm means 76 centimeter of Hg, and 1 atm is equal to 10 to the power 6 dynes per centimeter square. That you can tell, that is a 10 to the power 5 Newton per meter square. Okay, question is asked. Now next important relation I am telling you related to temperature. Temperature is expressed in degree centigrade or Kelvin or Fahrenheit, F. Then how they are related, you remember. Minus 273.15 degree, that is equal to 0 Kelvin, you remember. 0 Kelvin means minus 273.15 degree, that is equal to 0 Kelvin. Or you can tell 0 degree centigrade, 0 degree centigrade, that is equal to plus 273.15 Kelvin, or you can tell 273 Kelvin. Correct? 0 degree centigrade means, see, both are different. 0 Kelvin is equal to minus 273.15, that is a 0 Kelvin. Correct? And 0 degree centigrade means what? 273.15 Kelvin. Roughly you can tell 273 Kelvin. And T degree centigrade means T plus 273 K. Okay, remember, T degree centigrade means T plus 273 K. Now another point I am telling you. Boyle's law. Actually, I am reviewing the entire chapter, hence I am briefing, only brief. Already I have discussed in details. Okay, in that you can say 11th or 12th portion, I discussed in details. Now I am briefing. Before I can say multiple choice questions, you should know all the things. That's why I am briefing all. Then Boyle's law is equal to, what is the Boyle's law? Then Boyle's law, temperature remaining constant, the value of a given mass of gas is inversely proportional to its pressure. Correct? The volume of a given mass of gas is inversely proportional to its pressure. Mathematically you can write V is inversely proportional to pressure at a constant temperature. And also you can write, because V is inversely proportional to P, then if you want to make it equality, then you have to multiply it with some constant. Correct? Then you can write PV is equal to constant also. PV is equal to constant at constant temperature. Temperature is constant always in case of Boyle's law. Then V is inversely proportional to P. Then PV is equal to constant. Now equality convert this proportionality sign, you convert it into equality. And PV is equal to constant at constant temperature. You can write also P1 V1 is equal to P2 V2 at constant temperature. Then P1 V1 means initial condition, and P2V2 means final condition. Now I am telling about graphical representation of Boyle's law. Question is asked. They will give some graph and they will ask you this which one is Boyle's law. Boyle's law you can tell in 3 graphs. Question is asked. They will give the graph. Then you have to tell which one is Boyle's law. Which graph is telling Boyle's law? Okay. Then that is called graphical representation of Boyle's law. Boyle's law can be represented in 3 forms. Then first graph is that is the P versus 1 upon V. P versus 1 upon V. If you have data, actually graph means you require data. Without data, no graph. Then if P versus 1 by V graph, if you will draw, then you will find a straight line crossing through the 0. Okay, crossing through the 0, a straight line you will get. I will just this graph I will give you. I will give the graph. Okay, this is the one method to represent the Boyle's law. Second, PV versus P. PV versus P. Then you will find parallel to P. P is on x-axis. PV is on y-axis. First graph also P versus 1 by V. Then 1 by V was on x-axis and P was y-axis, vertical. Then now second PV versus P. Then P is on x-axis, PV y-axis. They will find a straight line parallel to x-axis, that is the base. This is the second way to represent Boyle's law. One more graph is there for Boyle's law. That is the V versus P. V versus V is y-axis, P is x-axis. Then if you will draw the graph, then you will find that on the y-axis V will be actually on the top. It will be just like a curve. Then here V value will be high and P value will be less. Okay, you will find a curve. Then starting from the V value will be high, and slowly as the pressure will increase, value of V will decrease. Again it will become just like not fully parallel, but it will come closer to x-axis. Means you will find you can say just like a vertical. Then these are the 3 representation of Boyle's law. Now Charles' law I am telling you. Charles' law. What is the Charles' law? Then you have seen in Boyle's law temperature was constant. Then in pressure and volume we are studying how pressure and volume are related. That was under Boyle's law. But here in Charles' law, pressure will be constant. Then what are the variables? Volume and temperature. Pressure remaining constant. The volume of the given mass of gas increases or decreases by 1/273 of its volume at 0 degree centigrade for every 1 degree centigrade rise or fall in temperature. You remember this concept is very, very important. You have taken gas. Pressure is keeping constant. Pressure remaining constant. Then if you will increase the temperature by 1 degree, or you will decrease the temperature of the gas by 1 degree, either increase or decrease. But when gas is at 0 degree, that time either you increase or decrease by 1 degree. In that condition, I am telling you, pressure remaining constant, the volume of a given mass of a gas increases or decreases by 1 upon 273 of its volume of 0 degree centigrade. Means what was the volume of the gas, given mass of gas at 0 degree, it will have some volume. Then that volume will decrease or increase by 1 upon 273 of its volume of 0 degree centigrade for every 1 degree centigrade rise or fall in temperature. Mathematically you can write Vt because temperature you are making change. Then Vt is equal to V0, that will be constant only in that volume. Further either it will you can say that temperature will, you have increased the temperature, then volume will increase, gas will expand. Then V0, that is a constant, plus every degree, for every 1 degree I can say volume will increase. Then in how much it will increase? The 1 by 273 of its original, of its volume, 1 upon 273 of its volume of 0 degree centigrade. At 0 degree centigrade, what was the volume? Keeping in mind that things at that time, what was the volume in 0 degree centigrade? If we will increase every 1 degree centigrade rise or fall in temperature, then it will increase or decrease by 1 upon 273. Volume will change by 1 divided by 273. Mathematically you can write Vt is equal to V0 plus V0 divided by 273 into T at constant pressure. Correct? Because why you have written V0 divided by 273 into T? Because in 1 degree, 1 upon 273, then in T degree, how much? You have to multiply. Then its value will be, what was the volume at 0 degree centigrade? That volume you are considering, the V0 plus V0 divided by 273 into T at constant pressure. Then after that, you know, V0 you can take constant, common you can take. Then in bracket you will get 1 plus T divided by 273. And after solution you will get, is after simplifying, V0 in bracket 273 plus T divided by 273. Correct? Then 273 plus T, you can write simply capital T. Then finally you will get V0 into capital T divided by 273. Correct? Then this also you can write Vt is directly proportional to T. Why you are writing directly proportional? Because V0 is a constant, 273 is constant. Then only T is variable, capital T. Then for the V and 273 you are making constant, then it will, you can write in a proportional sign. Then you will get Vt means volume at any given temperature will be directly proportional to T, capital T, or you can tell V in a general way, V is directly proportional to T at constant pressure. Okay. Then now same law you can write, means Charles law in another way also you can write. Same things you can write. Pressure remaining constant. Other form of Charles law. Pressure remaining constant, the volume of a given mass of a gas is directly proportional to its temperature in degrees Kelvin. Or you can write V1 upon T1 is equal to V2 upon T2 at constant pressure. Correct? Suppose you have heated the gas, then in the beginning volume was V1. After that heating, it became volume increased. It became V2. Suppose temperature was 50 degree, now it became 70 degree. Then 50 is the T1 and 70 is the T2. Then you can write V1 divided by T1 is equal to V2 divided by T2 at constant pressure. Today I am stopping only here. Next class again I will continue. Thank you.